ECM is not one universal motor or connector.
Integrated drives, separable modules, constant torque systems, variable airflow systems, and proprietary command interfaces require different service boundaries. A reliable diagnosis starts with the exact equipment, motor family, module revision, and OEM diagram.
Define the complaint before replacing parts.
No start, wrong speed, intermittent operation, low airflow, noise, overheating, fault trips, and continuous operation lead to different branches. Record the operating mode, controller request, interlock state, delays, ramps, and fault history before cycling power. The decision is broader than module versus motor. Build an evidence map across command logic, safeties, line supply, neutral and ground, harnesses, module or drive, rotor position feedback, windings and magnets, bearings, blower blockage, and system static pressure. A detected fault is not automatically the failed part. Before opening or disconnecting anything, isolate line power, controls, backups, automatic restart, stored capacitor energy, and rotation. Lock and tag the sources, verify absence of voltage, observe the specified discharge weight, and prevent windmilling because a permanent magnet motor can generate voltage. In the verified safe state, inspect grounds, connectors, pins, locks, harness rub-through, corrosion, moisture tracks, overheated terminals, module seals, wheel blockage, and bearing drag.
Connector color and wire color never prove function or voltage, and sealed electronics are not opened for generic component repair. Preserve OEM evidence before clearing it. Retrieve board and module codes, status data, event history, and sequence of operation information with the approved tool and procedure. Communication fault, motor fault, or locked rotor describes a detected condition. The OEM cause tree determines the next branch. Separate upstream command and supply evidence from the motor assembly only under the approved qualified person procedure. Exact test points, expected states, adapters, and risk controls come from the OEM revision. This film uses a diagram only, no live back probing, homemade jumpers, safety bypass, or unknown pin voltage injection. Mechanical load can make healthy electronics protect themselves.
With energy isolated, verify permitted free rotation, wheel clearance, bearing condition, debris, filter and coil restriction, and the specified system resistance evidence. Correct drag, blockage, moisture, overheating, or wiring causes before condemning a module.
Motor side tests are architecture specific.
Winding resistance, insulation testing, generated voltage, and bench commands require approved disconnection, test equipment, voltage, limits, adapters, and interpretation.
A megohmmeter can destroy connected electronics, and an exposed spin test cannot prove motor health safely. Module, sensor, and communication faults form separate domains. Power switches, rotor position feedback, temperature devices, harnesses, firmware, and programming can fail independently or as an integrated non-serviceable assembly. Classify the failure only as finely as the exact OEM procedure and evidence allow. Replacement is a programmed system decision, not a horsepower and connector match. Verify voltage, output, rotation, environmental rating, firmware or personality, communication protocol, torque or airflow profile, adapters, grounding, shielding, and equipment approval. Correct the root cause before installing a new module or motor. Final proof is equipment level operation, not a bench spin. Restore grounds, connectors, strain relief, ferrites, covers, guards, panels, and interlocks, then verify commanded modes, airflow or static pressure, current, temperature, sound, vibration, and fault-free operation. Close with a diagnostic passport linking each decision to measured evidence.